We don't need to do all of these. Once you figure out how
Yeah,
to do one or two of them, you're going to have it down.
yeah,
So how do I do 7? I don't, there's no, no, 7's the first one on this page. So let's start.
yeah. All right, so 7 is x minus 4 equals root 3x
What's the first step?
minus 8. So we're going to have to square both sides.
Okay. What's the right side become?
3x minus 8.
What's the left side become?
It's x squared minus 8x plus 16.
Very good. Most people get that wrong. I cannot tell you how many students I tell that if I ask that question, their answer is x squared plus 16. They leave out the middle term, always. Now, I got that. How do I solve that?
You have to bring the 3x minus 8 to the left side.
So what do I have on the left now?
So you'd have x squared minus 11x plus 24.
Okay. And that's equal to 0, because that's the only thing left on the right side is 0. Now, can you factor that? Try.
So add 11 multiplied by 24.
I'm not sure we've spent much time on factoring, have we?
Yeah, no, it'd be, one sec, x squared minus
I use
4x.
a different method than most people are taught. And
Okay.
I'm still convinced my method is the best method. I like it better than the California method or the diamond method. If you can do these, just give me the answer and I won't talk about it anymore. But if you don't know how to do this, I'm going to show you my method.
Okay.
All right, my method, first step, you split up the x's into x and x. Second step, you figure out both signs. Not one sign, but both signs. What do both signs have to be?
Negative.
Correct. Now we're looking for factors of 24 that add, because that's a plus, to the number 11. What factors of 24 add to 11?
In
8 and 3.
they're 8 and 3, yeah.
So what are my solutions?
3 and 8.
Now, whenever you have a radical sign, you have possibilities that one of these solutions doesn't work.
Right.
There's three things. You know what I mean when I say extraneous solutions? Yeah. Be sure to check for extraneous solutions. The way you check is to plug in both your answers and make sure that both of them give you an equation that is proper. So let's do it. Plug in 3. What do you get?
So you plug it into the original equation, right?
Always, yeah.
So 3 minus 4 equals the square root of 9 minus 8.
Square root. What's 3 minus 4 equal to?
There's negative 1.
Okay, let's put that there. Now the square root of 3 times 3 minus 8. Is that a true statement?
No.
That's not one of the solutions then.
Yeah.
Now, we can be pretty certain that 8 is going to be a solution. But just for the heck of it, let's try it. Plug in 8, what do you get?
Okay, so 8 minus 4 is just 4. And then, 3 is 24, minus 8 is 16. Square root is 4. So, yeah, it would work.
That's true. That's a solution. But this is a great example of where one of your solutions is extraneous. And
Yeah.
there are 3 basic things that really produce extraneous solutions you got to be careful about. One is radical signs, the other is absolute value signs, and the third one is logs. Any of those 3, if you're solving an equation that has any of these 3 in it, make sure you check for extraneous solutions. If it's just a polynomial, not so much. If I've got x squared minus x minus 2 equals 0, I'm going to come up with an x of, let's see, that's 2 and 1, negative 1, okay? But that's an equation that doesn't have any of these 3 things in it. It doesn't have a radical sign, doesn't have an absolute value sign, doesn't have logs. So I'm pretty comfortable not checking for extraneous solutions. I've never found a polynomial yet that produces an extraneous solution. So it's not regular polynomials that do it. It's the kind of problems that are on this page. Notice that everything on this page has either a radical sign in it or a fractional exponent, which is the same thing as a radical sign. In other words, a 1/3 exponent means cube root. 2/3 exponent means cube root of x squared. That's what that means.
Right.
Okay. So 8 is pretty much the same as 7. Let's not do it. Let's try to do a different type problem each time, especially if you are showing an understanding of it, and you are. So I don't want to waste time doing another problem that's exactly the same as number 7. Number 9 is a little different. What do I got to do with number 9?
So you have to subtract the 1 to the other side?
Yeah, you got to isolate that. In other words, you cannot square both sides until you get the radical sign isolated. So I'm going to end up with this. The square root of x plus 5 equals x minus 1. Now what?
Then you have to square both sides.
So what's the next line?
So x plus 5 equals x squared minus 2 plus 1, or 2x plus 1.
2x plus 1. There you go. Now you got a quadratic. We're going to solve it just like we did the other. I'm going to move everything to one side, factor it, come up with solutions, test both solutions, throw out the one that doesn't work. The only difficulty of this problem, or the only difference between 9 and 8 and 7, is the fact that the radical was not isolated to begin with. It had this plus 1 being added to it. You got to get rid of anything that is affecting the radical sign. So what am I going to do on 10?
But we only have to do odds on this one.
Okay, let's go straight. That's good because 10 is the same as 9. So, okay, so I see what they're doing is they're making 2 problems.
They do like the same, and then she's only making us do one.
I love that, actually. I really do like that a lot. Because
to start it, go back and
doing number 7, then I could show you how to do it, and then I would let you do number 8. Okay? So the fact
Yeah.
that they're basically giving you two problems that are exactly the same, not 7's the same as 8, 9's the same as 10. So let's go to 11. This is a little different because it's got two radical signs in it.
Right.
These are tougher. What do you have to do here? There's a certain strategy you have to employ when you have two radical signs.
So you would add the root x plus 1 to the other side.
Okay. Hope you can read all that. Sorry, I have to write over top of the print, but I have found that this is actually the best way to tutor, as opposed to having a blank sheet of paper and having to recopy the problem each time.
Right.
So now what do I do?
So you square root both sides.
Okay, what's the left side become?
Or square both sides.
I knew what you meant.
So squared.
That's easy.
Yeah, plus.
Now, square that using FOIL.
Yeah. Okay.
So,
Let me
in other
just.
words, 1 plus square root of x plus 1 times 1 plus square root of x plus 1. FOIL that. You know what FOIL means, right?
Yeah.
I always ask that because not everybody gets taught FOIL anymore.
Totally.
FOIL is a little antiquated. A much better term is ET. You're going to multiply every term by every term. And that works whether you're dealing with binomials or trinomials or four-term stuff. FOIL really only works when you have a binomial times a binomial, which we do here, so we can get by with FOIL. But just a reason why I prefer to call it ET rather than FOIL. So if you're doing either one, what's the answer here?
Would be like 1 plus root x plus 1 plus root x plus 1 plus root x plus 1 squared.
Which is?
X plus 1.
So that's what that is squared. So what is that? That is x plus 1 plus 2 root x plus 1, correct?
Mm-hmm.
So now I have this equation, and you can see what's happened is I've taken it two radical signs and turned them into only one.
Yeah.
So now I want to isolate the radical sign and square both sides again. So what's the next line here? In other words, all of this stuff that's not the radical sign has to be gotten rid of.
So we have to take the x plus 1 to the other side.
Okay, so that leaves x plus 2 equals 2 root x plus 1. I think I did that right. Yeah, okay. Now what?
Divided by 2.
Now what?
Square both sides.
Good. So on the right side, we're going to have x plus 1. And on the left side, we got x plus 2 over 2 squared. Let me erase some stuff here. One problem is I write really big, and these pages aren't big enough for me. I really think writing big is good for teaching, as opposed to having tiny scribbling that you have to squint your eyes to read. That's where I'm at, right? Isn't this where I left off?
Yeah.
Okay. Do the left side.
Okay. So if we square that.
Square the top and the bottom separately.
Okay, so the top would be x squared plus 4x plus 4.
I love the fact, incidentally, that you're able to do that quickly. You're not foiling that. You're using your knowledge of what is a plus b squared.
Yeah.
That's a great thing to know because you have to do it so much in math. You have to do a binomial squared. And to know what it is avoids you having to take 30 seconds to FOIL it.
Yeah.
What's the denominator?
Just 4.
And that's equal to x plus 1. What next?
Right. To get rid of the fraction, or just like multiply by 4, like the whole thing.
Correct. What's next?
4x. You have to bring the 4x plus 4 to the other side.
Well, when you see a plus 4x on that side and a plus 4x on that side, you can cross them out as long as they're both being added and they're not multipliers. And when you see a plus 4 there and a plus 4 there, and when I cross them out, I'm leaving 0. So what I end up with are x squared equals 0.
So x equals 0.
X is 0 is the only solution that I can come up with.
Yeah.
Now let's plug it in and see how it works. What are we doing? Number 11?
Yeah.
Okay. When I plug in 0, I get square root of 3 minus square root of 1 equals 1. Well, that's not true.
So there's no solution.
Square root of 3 minus 1 equals, oh, hold on. Yeah, no, it's square root of 3 equals 2. Whenever you have a number equals to another number, it means there is no solution. Do you have answers on these? Do you have answers on number 11?
Yeah, let me find it really fast.
Go ahead and find it. That's an odd answer for the very first problem that has 2 radical signs in it.
Yeah.
So I want to check make sure we have the arithmetic error.
Yeah.
Because it's easy to make on these because you have so much multiplying and squaring to do.
Yeah. So number 11.
Uh-huh.
Let me see. I have to download this.
Uh-huh.
Number 11.
Seems like x equals 3 gives you
the
square root of 9 minus the square root of 4. Is that equal to 1? Yeah, it is. 3 minus 2 equals 1. So 3 is the answer.
Yeah, it looks like so is -1.
Oh, -1 is also the answer?
Yeah.
Yeah, you're right. It is. -1 also. So what's that tell us? Tells us we did our math wrong.
Yeah.
Made a mistake somewhere. And I don't even know where it is. But I made a mistake somewhere.
It looks like
it's easy to make a mistake. And I could go back and start it from the beginning, but I kind of feel like that would be a waste of time.
Yeah.
As long as you understand, it's not getting the answers right that matters as much as doing the method correct.
Yeah, no, I can just find it later.
Well, here's the thing. Whenever you see 2 radical signs, you kind of have to eliminate them one at a time. In other words, you isolate one of them by moving the other one to the other side. You square both sides, that gets rid of that radical sign, but you still have a radical sign on the right side. Then you isolate that radical sign and you square both sides again. So there's a lot of math to be done, a lot of arithmetic. So it is extremely easy to make a mistake, which I apparently did when I went through all the math.
Yeah.
But the method is always the same. That's what you're always going to do. You're going to do 12 the same way. I'm going to move that to the other side. Then I'm going to square both sides, which gets rid of that radical sign. Still have a radical sign now on the right side because I'm going to have 2 plus square root of 2x minus 4. And when I square that, that leaves me still with a radical sign. Then I have to isolate that radical sign by moving everything associated with it to the other side. And now I'm left with just one radical sign. And I can square both sides again. So whenever you have 2 radical signs in a problem, you're going to have to square both sides twice. And both times it's going to be a difficult process to square.
Yeah.
Yes, whenever you're squaring numbers like 1 and number 11, it was this, okay? So our first step was to square that. And it's possible that I made a mistake. We did 1 plus 2 of those plus x plus 1. That is what that squared is. I don't know if that's what we came up with last time or not. But the next step would be to try to isolate that. So I got to move the ones, I got to move that over, I got to move that over, I got to move that over, and then I got to divide by 2. And then I will have the square root of x plus 1 on the right, and whatever I have on the left will not have a square root in it. But I still have to solve it by squaring both sides. In other words, however many radical signs you have, you're probably going to have to square both sides that many times.
Right.
All right. So let's look at a slightly different one, number 13. Rather than trying to get to the bottom of my math error, that's just an exercise in arithmetic. I'm quite certain that I made a math error, and I really don't want to spend 10 minutes trying to figure out where it was. I think it's more suitable for you to move forward. So what do we do on 13?
We have to just cube both sides.
Okay. What's the left side become?
X plus 1 equals negative 27.
So x is equal to minus 28. Now, if I plug that in and check, minus 28 plus 1 is minus 27, and the cube root of minus 27 is minus 3. When you take cube roots of negative numbers, you get negative numbers. It's not plus or minus like square roots. It's odd roots produce the same sign as you start with. So that's relatively easy. 14, same way. 15, what am I going to do?
15, you do the same thing. You got to cube both sides.
Yeah, it's going to be easy after that. In other words, then I'm going to have 3x squared plus 7 equals 7 minus 4x. I'm going to have to solve that quadratic again. I'm going to come up with 2 solutions. And I definitely want to check both solutions.
Mm-hmm.
In other words, I would say there's a high probability that one of those solutions does not work. And it's not only
Right.
because we have radical signs, but we have an x squared. Let's do that real quick, just to see if I'm right. We got 3x squared plus 7 equals 7 minus 4x, right?
Mm-hmm.
After I cube both sides, you know, 7's cancel.
Right, so it's 3x minus 4x. Or 3x squared minus
X
4x.
squared plus 4x equals
Plus 4x.
0. Factor out an x. You got this equals 0. What are my two solutions?
X equals 3/4 and x equals 0. Or 4/3.
It's negative 4/3
Negative 4/3.
and x equals 0. Let's try the easy one.
Yeah.
0 is the easy one to test. Does 0 work? Is the cube root of 7 equal to the cube root of 7?
Yes.
Okay,
So
so
0
it
works.
works. Now let's try negative 4/3. I'll bet this does not work because when I square it, it's going to turn positive. So I'm going to have the cube root of, let's see, negative 4/3 squared is 16/9 plus 7. Is that equal? And you always do have to go back to the original. In other words, I can't check both of these answers after I've already cubed both sides. I got to go back to the original formula. So let's see. Over here, I got the cube root of 16/3 plus 7. Is that equal to the cube root of 7 plus 16/3? Yes, it is.
Yeah.
The argument under the cube root sign is the same. It's just in different order, but it's the same number. So oddly enough, both these solutions work. Surprise to me, because I didn't think, I was sure one of them wouldn't work. You have answers? Are your answers in front of you, or do you have to look it up each time?
Yeah. Yeah, here. One sec.
Well, make sure you tell me if I get it wrong. In other words,
Yeah.
is this what it says? Minus 4/3 and 0?
For number 15. Yep, those are both correct.
Okay. Keep me honest here.
Okay.
16, same thing. Same problem.
Yeah.
Just going to cube both sides and solve the quadratic. It's even similar to the point where that's squared. They didn't do anything different other than change the numbers. It's a little sick, but okay. So 17, what am I going to do?
So you have to take the 4 to the other side.
Okay, so now I got 4th root. Yeah, you always want to isolate the radical sign, which we've done. Now what?
And then you want to and then you want to just like times both sides to the 4th.
Yeah, let me show you a different way of looking at this. That is the same as this. Correct?
Mm.
Well, if I want to get rid of that 1/4, I got to take each side to the 4th power. And then 4 times 1/4 is 1. So I'm left with x minus 2 equals 16, which means x equals 18. And
Yep.
if you look at x equaling 18, then you're taking the fourth root of 16, which is 2, plus 4 equals 6. Again, you have to go back to the original equation to test it. 18, a little different.
Right.
Let's write it different because it's not obvious as to what to do. Let's write it with fractional exponents instead of radical signs.
Okay.
Now, what to do?
So we have to uh,
What are we going to do to each side?
we have to just multiply it by, or
Nope,
no, we have,
multiply it. Got to exponentiate it. By what?
right,
By 4 or
1/4,
2?
4.
Yeah, if we did it by 2, we'd get rid of this 1/2 on the right side, but we'd still have a 1/2 on the left side, which means we'd still have a square root sign. Whereas
Right.
if I do each side to the fourth, now the left side becomes 2x plus 3, and the right side becomes x plus 1 quantity squared. Now that's an easy problem. Just square the x plus 1. It's a quadratic. Put everything on one side, factor, solve it.
Yeah.
And by all means, test your two solutions, because quadratics are always going to give you two solutions. So that was a little tough. I don't know if it helped or not putting it in fractional exponents. I kind of think it did. I'm not sure I would have seen the solution as quickly as if I'd have left it like that.
Right.
It would have been a little harder. Once you put it in fractional exponents, it's quite a bit easier. How am I going to do 19?
So it's x to that. So you have to multiply each side by 5/2.
Exponentiate each side by 5.
Exponentially, you're right.
Not multiply. There's a big difference. Multiplication or exponentiation is to multiplication as multiplication is to addition. They're different
Right.
steps. Okay,
Right.
that makes the left side x, makes the right side 4 to the 5/2. What is 4 to the 5/2?
The square root of 4 to the 5th.
Good. Always do the root first. Always.
Right.
Because otherwise you're taking 4 to the 5th power, and who the heck knows what that is? You got to use a calculator if you're going to do it that way. So if you take the root first, the square root of 4 is 2. 2 to the 5th, I know what that is, 32. So by taking the root first, you can eliminate the calculator. They don't want you to use a calculator to figure that out. They want you to do it this way. You take the root of 4 first, the square root of 4, and then you take that answer to the 5th power. 20, what's my first step?
21 or 20.
Just 20.
Okay. So you have to exponentiate to the 3/2.
Okay, now 21. First step on 20.
Yeah. You have to add 5 to the right side.
Second step.
Do you have to divide by 2 or can you just exponentiate?
You have to divide by 2 because that 2 is not being taken to the 1/3 power. The 1/3 exponent only applies to what is beneath it, x.
Right.
So if I cubed both sides, it would turn into 8x. So that just introduces bigger numbers. So let's divide both sides by 2 first to produce that. And now when I cube both sides, x equals 27. I never had to deal with big numbers. Whereas if I had decided to cube both sides first before dividing by 2, here's what I would have had. 8x equals 6 cubed. I got to get my calculator out. See the difference?
Yeah.
Always keep numbers as small as possible if you have a choice. And we have a choice.
Yeah.
I don't need to cube the 2x. I only need to get rid of the 2 and then cube the x to the 1/3. And by doing that, all my numbers are less than 27. Never had to pull out a calculator. I got to pull out a calculator to do that. I don't even know what 6 cubed is, let alone what 6 cubed divided by 8 is. Well, actually, I know 6 cubed divided by 8 must be 27, but I didn't know that before. All right. 22, same thing. Gonna subtract 5 from both sides and then do what?
Divide by 4, then exponentiate 2/3.
Perfect. 23 looks different by a lot. It's actually a very interesting technique to use on 23. You might think that the way you would do 23 would be this. But this turns it into a nightmare. If you try to do it that way. I'd have to find a common denominator. I'm not even sure how I'm going to solve it if I do it this way. There's an interesting technique that you can use on this problem. And that is to recognize that is a quadratic. Notice that the first term is the square of the middle term. In other words, x to the minus 2 is the square of x to the minus 1. So let me show you a technique here that works pretty nice. If you let u be the middle variable, this whole thing turns into u squared plus 3u plus 2 equals 0, which factors quite nicely into u plus 2, u plus 1 equals 0. So my answers are u equal minus 2 or u equal minus 1. Now go back and substitute x to the minus 1 for u. So now I have 1 over x, which is x to the minus 1, equals minus 2. Solve that.
So we x equals.
Multiply both sides by x, divide both sides by minus 2.
Okay. So, yeah, 1/2.
Okay. The other one said u equals minus 1. Well, u is 1 over x equals minus 1. What is x equal to?
Just -1.
Negative 1. Again, you're multiplying both sides by x, and then you're dividing both sides by whatever that is.
Yeah.
So our answers are x equal minus 1/2 and x equal minus 1. And that's this problem 23. So let's check both of those solutions. So let's see. If x equals minus 1/2, let's just do it this way. In other words, substitute first and see if that's a proper equation. Right?
Mm-hmm.
What's minus 1/2 to the minus 2 power?
Do you square
Yeah, this is a little tough. We're not used to doing this kind of algebra. Don't want to get rid of our second solution there. All right. First of all, minus 1/2 to the minus 2 is the same as 1 over minus 1/2 to the 2. For starters, that's what you do.
Mm-hmm.
Now, what's the denominator become?
Is it? I forgot how to square. Don't you? Do you,
Square top and bottom.
square top and
Minus
square bottom?
1/2 times minus 1/2.
So it's just minus 1/4
Well, no, it's plus 1/4.
plus 1/4. Yeah.
In other words, minus 1/2 squared is plus 1/4. Now I got 1
Right.
divided by plus 1/4, that's 4. That's what minus 1/2 to the minus 2 is 4. Now let's figure out what the second part is. 3 and minus 1/2 to the minus 1 means 1 over minus 1/2. That's minus 2 times 3 is minus 6. Plus 2 equals 0. That is a valid solution. So x equal minus 1/2 is correct. Now let's try the other solution, which is x equal minus 1. This should actually be easier to do. But nonetheless, let's lay it out. This may be an extraneous solution. We don't know. So we got, remember that's 1 over x squared. So it's 1 over negative 1 squared plus 3 times 1 over negative 1 plus 2 equals 0. Well, what's that equal to?
Just -1
No.
or 1.
What's the middle term equal to?
-3.
Plus 2 equals 0. True statement. Both solutions are valid. That one and that one. So far, we haven't found one that had an extraneous solution, have we? Did we find any?
Yeah. I don't think so.
Huh?
Oh wait, no. I think one of the first ones did.
Maybe one of the first ones. Yeah, yeah. In fact, maybe this very first one did. I can't remember, but it seems like we haven't found many that had extraneous solutions. All right. So 24. Tell me how I'm going to do 24. And notice
24.
how much easier that technique was than doing it using the fractions and having to find common denominators and all of that stuff. At least to me, this substitution method is a much better method. So let's use it on 24 also. So if I'm going to use the substitution method, what is u going to equal?
Z
It's a key issue. Have you had trig yet, Hayden?
No.
Well, you get the same thing with trig. If I had a question like this, that's a quadratic. It's a quadratic because this term is the square of that term. That's all you need for a quadratic, is for the leading term to be the square of the middle term, and you have a constant. So we're looking at a quadratic here on 24. But in order to easily put it into a quadratic form that you're used to looking at and can solve easily, we have to use this u substitution. So what's u going to be?
Right.
It's always the term that's not being squared. In other words,
So
that term.
just x. Okay.
Now rewrite this thing in terms of u.
So 2 and then x minus 1.
Huh? U. We're doing 24. So
Yeah,
what's
so
x
u
to
is
the minus 2? If u is x to the minus 1, what is x to the minus 2 going to be? U squared.
okay.
Notice that if you square both sides on top, you get u squared equals x to the minus 2. So this term right here becomes 2u minus what?
Minus u.
Excuse me, that becomes 2u squared. My apologies.
Yeah.
Minus u. The 3 is on the wrong side. I want to bring it over and put it here.
So minus 3.
And now I have a normal looking quadratic that you can factor.
Yeah.
Factor that. Be 2u and u.
Yeah.
Signs.
Negative and positive.
Correct. Only I gotta kind of write it like this because it could be positive negative or negative positive, and they are different. They are different whenever the coefficients of the u are different. If the coefficients of the u are the same, whether it's u times u or 2u times 2u, then plus minus is the same as minus plus. But if they're different, you have to allow for both of them. And we don't have a lot of choices. The 3 can go on the left with either of those signs, and the 1 goes on the right, or vice versa. So there's 4 possibilities. Do you know which one is the answer?
So going right.
Let me tell you how I would do it if I didn't know the answer. I would just randomly start. I would put a 3 there and a 1 there. There's only 2 factors of 3. That's 1 and 3. So I don't have a whole lot of choices here. I can put the 3 and the 1, or I can put the 3 down here with the negative sign and the 1 over there, or I can switch the numbers. So I got 4 possibilities. Now, to figure out which is correct, let's check the middle term. It's always the middle term that's in doubt. What do I get for a middle term with this arrangement?
You get
And I draw these two smiley faces like this because this is the inside, that's the outside. So it's the O and the I of FOIL. That always
Right.
produces the middle term. So this is plus 3u.
Mm.
The
So you
outside is
just you.
minus 2u. Add them together, you get plus 1u.
Mm.
Well, we got the right
So
number, but the wrong sign.
we just gotta flip the signs.
Is all I got to do is, no, I move the 3 down to the negative. Yeah, you swap the signs. You don't swap the numbers. You swap the signs.
Yeah.
So the 3 goes down to there. The 1 goes down to there. And
Yeah.
and that's our answer. Well, let's get to that in a second. Notice that I never have to do all 4 possible combinations because the moment
Right.
I pick one, if I don't get the right number, then I'm immediately putting the 3 on the right side and the 1 on the left. Because I know if I don't have the right number, moving the 3 down and the 1 down gives me the same number, just a different sign. So if my first attempt does not produce the right number, then I don't have to do the second possibility. I just switch the numbers and go from there. And I'm never going to have to do more than 2 trials. I will always be able to figure out my answer with a maximum of 2 trials, even though there are 4 combinations.
Okay.
That's a key point in solving these quadratics that are not elementary quadratics. I call a
Right.
quadratic that has anything other than a 1 there, it's not an
Yeah.
elementary quadratic. It's a more difficult quadratic to factor. And
Right.
that's where it becomes a trial and error process. And perhaps even the California method or the diamond method works better on these higher degree quadratics. But in terms of simple quadratics, where that coefficient is a 1, there's nothing that beats my method. My method is 4 steps at the most. They're always the same. There's no trial and error involved. But
Yep.
when you get to a higher level quadratic, there is some trial and error. You have to use trial and error to attempt to produce the middle term. Okay? So
Yeah.
now I got to switch it back to x because I'm trying to solve for x here, not u. So first of all, what are the solutions for u? U is equal to 3 halves and u is equal to minus 1, correct?
Mm-hmm.
So that means x to the minus 1 is equal to 3 halves, which means 1 over x is equal to 3 halves. You can solve that. X equals 2/3.
Yep.
And also x to the minus 1 is equal to our other solution, which was minus 1. In other words, u was minus 1 in one of our solutions. And so u is equal to x to the minus 1. So I get 1 over x equals minus 1. X is equal to minus 1. So my 2 real solutions are 2/3 and minus 1.
Okay.
Okay? Those are definitely a little trickier. But this little substitution, did they teach you this in class at all? Using this technique?
No, they didn't.
Man, this problem becomes, I'll let you go here in a second, but let's just look at this problem if I don't use that technique. Here's what I'm looking at. 2 over x squared minus 1 over x equals 3. I guess I can solve that with a common denominator.
Mm-hmm.
I got 2 minus x over x squared equals 3. Now I got 2 minus x equals 3x squared. So I still end up with a quadratic. That might even be an easier way to do it. I don't know.
Right.
But it probably is easier. I was probably mistaken in thinking that this U substitution was the best way to go. It turns out that these two fractions are not that hard to operate on because the common denominator is x squared in both cases, so it's not that hard to do.
Yeah.
Even still, this U substitution method you should learn because it applies to a lot of things. If I have something like this, that is a quadratic. The first term is the square of the middle term. So if I wanted to know how to factor that, I would let u equal to e to the x, and then I would have u squared minus u minus 2. I can factor that easily. Go back and resubstitute it after I factored it. So this technique is actually very valuable. I'm not sorry I taught it to you. But it turns out the problems they're giving you here could actually probably be solved a little easier by not using that technique. Not even recognizing that it's a quadratic, just go ahead and write it out in terms of x and then solve it. All right, Hayden?
Cool. Thank you.
Have a good night. I will talk to you next time.
Goodbye.
All right, bye-bye.